Assalamualaikum. My name is Nafisa binti Ali and my number ID is EA19023. And today our group wants to present about Lab 2 and I would like to explain about question 1 part A. And this question we can derive the equation of the magnetic flux density vector at point P for the line current I. And this formula we will use, and then this equation we use to use integral table, and we simplify to get this equation. And then from the equation they are given this, and this number we put this equation, and then lastly we can get this final equation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amira Atika binti APKD. My ID number is C19084. Okay, I will explain the calculation for part A2. Firstly, we need to find the magnetic flux density when H change from -5 to 5. So, I decided to use Excel to make it easy to plot graph. And lastly, we get the graph is shown in the figure.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Fadila binti Ibrahim. My ID number is EA19042. And today I would like to explain for the coding at the MATLAB. And first we have to set the lowest and highest point at X minimum, X maximum, Y minimum and Y maximum. And then we have to set the number of segment or for each line current, which is number of division is 100. And we have to compute the step size in both X and Y direction. And then this is our information of the line current, which is our current is 5 ampere. This current is already stated in the question. And then we have to set the number of floating point along X and Y axis. Our number of floating point is 10. And then we also have to set the minimum and maximum floating point on the plane, which is our minimum started from -5 until 5. And also we have to compute the step size in X, Y and Z direction. And then we just run this simulation and we will get the graph for the magnetic flux density versus H. From this graph we will get the output for the views for the three-dimensional views. From the three-dimensional views we can get the two-dimensional views, which is here. Which is XY view, XZ view and YZ view. As we can see here, the value that we get in the MATLAB is 7.0711 exponent -7 is already same as the calculated value, which is for the question in part A. So here we get the same as the MATLAB simulation result. And this is our second coding for the question part B, simulation analysis. And this coding is also the same, which is we have the free space for pi 10 exponent -7 and our current is 5 ampere. And we just run this simulation and we will get the graph of the magnetic flux density versus H. So here we can see that this graph is starting from the minimum value, which is -5, until maximum value is 5. So that's all from me.
Thank you, Tila. My name is Fang Xiong. I would like to continue to present our lab discussion. In our discussion, the graph that we get in simulation result in figure above. You can see that the value of flux density will increase when distance of point P toward line charge is decreased. From that, the value of flux density will be increased when the value of current through the line charge is increased. Moreover, when the distance or the radius of P from the line charge decrease, the value of current will increase. After that, the plot magnitude of magnetic field density versus H at point P when H is changed from -5 to +5 was proved in calculation for part A2. From the calculation, all the value of plot magnitude of magnetic field density versus H is same in the coding part B. Simulation result below in figure 7 show that the coding from B was combined with coding from A, because run the simulation in the same common window. The above plot is from coding A and it reflects to the negative axis from coding B. The result in common window that student calculate is same as in MATLAB simulation, which is 7.0711 power of -7. That's all for us. Thank you.